Hey everybody. Today we're solving some equations involving logarithms. First of all, let's remember the definition of a logarithmic function. Log base b of x equals y means b to the y equals x. So every basic logarithm can be written in an exponential form like this. For instance, log base 2 of x equals negative 2 means 3 to the negative 2 is x. So in this situation, x is just 1/9. Two other very important properties to keep in mind when solving equations involving logarithmic functions are the one-to-one property. If two equal logarithms have the same base, then the argument, the inside, has to be the same. And the inverse property. The function b to the x and the function log base b of x are inverses. So b to the x undoes a logarithmic function. The x greater than 0 here is just the domain of the logarithm. We can't plug in values less than or equal to 0 into any logarithm. Let's do some problems. Here's the 4 that we're going to do. Problem 1, 2 plus ln x equals 11. The idea is to get the natural logarithm alone on one side of the equation and then to undo it using an exponential function, in this case e to the x. So I subtract 2 from both sides to get ln x equals 9. And then take e to the x of both sides. The e to the x and the ln of x undo each other, so I'm left with x equals e to the 9th, about 8,103.1. Problem 2. Log base 7 of 3x minus 1 equals log base 7 of x plus 3. Here I have two equal logarithms with the same base, so I'm going to use the one-to-one property. The insides have to be the same. 3x minus 1 equals x plus 3. I collect all the x's on one side, put all the constants on the other, 2x equals 4, and then solve for x by dividing by that coefficient of 2. So x equals 2 here. Problem 3. Log base 2 of 3x plus 5 equals 2.7. Here, I'm going to get rid of the logarithm just using the definition. 2 to the 2.7 is 3x plus 5. Basically, I've written that logarithmic equation in exponential form. 2 to the 2.7 is about 6.50. Now I subtract 5 and divide by 3 to get my answer. It's about 1/2. Problem 4. Log base 10 of 5x plus log base 10 of x minus 1 equals 2. Okay, so here I have multiple logarithms, but also a constant. So in this case, I'm going to want to use a property of logarithms. The log of a product is equal to the sum of the logarithms. Again, always be careful to make sure you have the same bases on those logarithms when using this logarithm rule. So that log base 10 of 5x plus log base 10 of x minus 1 can be rewritten as log base 10 of the product, 5x times x minus 1. All of that has to equal 2. Now I can get rid of the logarithm using the definition. 10 to the second equals 5x times x minus 1. Expanding out that 5x times x minus 1 and bringing the 10 squared over to the other side, I see that I have a simple quadratic function. And I can solve this either using the quadratic formula or by factoring. This one factors very nicely, so let's do it that way. Overall, we get x equals negative 4 and 5. Those are the solutions to that quadratic equation there at the end. Now, one thing to watch out for here. In this case, we got two roots to the quadratic, negative 4 and 5, but only 5 is actually a solution to this problem. If I take x equals negative 4 and plug it in to the original formulation of the problem there at the top of this slide, I get the logarithm of a negative plus the logarithm of another negative. And the domain of the natural log, or the domain of the log base 10, or any logarithm, is only positive numbers. So negative 4 just doesn't work. What happened here is that when we applied that logarithm to take the sum of the logs to get the log of the product, we ended up taking the log of a negative times a negative, which is, of course, a positive. And that introduced this false solution of negative 4. Bottom line, when you're solving a logarithmic equation, especially using log rules like this one, you want to check your answers at the end to make sure that they work, to make sure that they are actually in the domains of the logarithms that you're using. In this case, the only answer to our equation is x equals 5.